Anyway, good afternoon, everybody. I'm Malcolm Bowman. I'm a professor of marine sciences at the School of Marine and Atmospheric Sciences down on South Campus. And we're here today to talk about new fields of sustainable energy, the big challenge before us. And we have a distinguished panel here. It's called Energy Campus Initiatives, Plans and Dreams for a Sustainable Campus. So on my immediate right is Professor Devinder Mahajan, who is a professor of chemical oceanography, director of graduate studies in the chemistry department, and has a long history in research in gas systems, both the Brookhaven National Lab and the Stony Brook. Next to Devinder is Terence Harrigan, who's the Associate Vice President for Campus Operations. Have I got that right? You do. And has a long history in almost 50 years experience. Is that right? 50, 30. In making campuses work the way they should, and has a lot of responsibilities, different places to Stony Brook. How long have you been to Stony Brook, Terence?
I've been here 18 years.
18 years.
Yeah.
I first met you when you were, I think, Director of Transportation.
That's right.
On my far right is Van Sullivan, sorry, who is CEO of the Faculty Student Association at Stony Brook, and he's been at Stony Brook now since, I think, 2018. Came from the University of Massachusetts at Amherst, and his responsibility is to make life civilized for our students, and to treat them well, feed them well, make sure everyone's housed in a healthy way, and generally make the experience at Stony Brook a very rewarding one. So it's a sort of an eclectic group. I'm actually an oceanographer, but I have an engineering background. So I'm going to ask you, Devinder, sort of to kick off this discussion about what you do, your research interests, and how do you go about it, and where do you think we're going in this climate change business?
So, thank you, Malcolm. I think first, thanks for inviting me to join this panel. So, just to introduce myself first, on the education side, I'm a professor of chemical engineering.
Chemical engineering.
And on the research side, so my field of research have evolved from when I started at BNL from oil and gas to renewables now.
From oil and gas to renewables.
Right.
When I first knew you, you were studying methane hydrate.
Yes, we were looking at, even at that time, you mentioned about methane hydrates. We were looking at how these large deposits of methane that is below the ocean floor in permafrost.
Yes.
What happens if the temperature rises? Then you don't have to do anything; they will just start coming up by itself.
No.
So it was a issue then.
Yes.
And now actually is a more urgent issue now.
Yes.
So with that background, so going forward, at this point, we started a institute called Institute of Gas Innovation Technology, which is located in the R&D Park.
Across the street, Stony Brook Road.
Exactly, and our focus at this point is what I call them is somebody asked me what do we do, and I have given probably like last 50 lectures in the last 3 years all over, and I said we do only one thing. We look at hydrogen, CO2,
carbon dioxide,
and methane.
and methane.
So those three molecules we play with. And why do we do that? Because CO2, of course, is the consequence of burning carbon.
Yes.
And it has to come from a carbon source.
Yes.
But going forward, can we then switch over to non-carbon molecules to produce energy?
They can produce
like hydrogen. Because if you are starting with hydrogen, then when you burn, you produce water.
Yes.
Then there's no CO2.
Where do you get the hydrogen?
Well, that's $1 million question. Actually, more than $5 million question. we'll discuss that
All right.
later on, but I just want to give the floor to my colleagues here. But you know what, just want to start with this. I know there's a lot of pessimism about climate change,
Yes.
but just don't forget that the technology is also evolving very, very fast.
Yes.
So I'm an optimist
That's good to hear that.
by nature.
Yes.
So what I see is not just what the measurements are telling us,
Yes.
but that's a pessimism in the sense when you see the number, you say, what the heck? What am I going to do with this?
Yeah.
We look more where the technology stands
Yes.
and what can we do to arrest warming of the planet
Yes.
in the coming decades.
Yes.
And that's what we'll be addressing through this discussion. I just want
Thank
to, just to start, I just want to,
Sure. So I'm Terrence Harrigan. I'm Associate Vice President of Campus Operations and Maintenance. Responsibilities for power plants, heating and cooling plants, cogeneration plant, which is a 43 megawatt facility that generates all of our electricity on our east and west campuses, as well as the waste steam is used for producing air conditioning and heating for all campuses and hot water for all campuses. With backup boiler plants that also are used as backup facilities for heating and cooling needs if cogeneration goes down. Responsible for a lot of the trade services, carpentry, painting, electrical, high voltage in all of our buildings, utility management. But one of the big areas that we focus on in my group, and it's been a charge from the state of New York, is energy management and the stewardship of our resources and how we generate our power and how we generate our services for our buildings. So we've been very active here at Stony Brook with many different energy reduction projects through the last 15 and 20 years, where we've been able to flatten out our consumption curve and load, meanwhile growing in square footage by close to 3 million square foot. But there's clearly lots to do as far as lowering our consumption loads, but as well as migrating over to alternative energies and different technologies outside of carbon technology. So that's something we're very actively in the process of pursuing and working with New York Power Authority on developing certain energy strategies for all of our campuses that migrate us towards alternative energies, as well as helping us meet our goals and our mandates for different reductions in greenhouse gases or 100% renewable energy. There are very ambitious goals that are set out within the industry and within the State University of New York that we're anxiously and ambitiously working towards as we create our plans to move towards. So that's been helpful.
Thank you, Terrence. It sounds like you have a very busy job and an ambitious agenda that you're faced with.
Yes, it's the campus is a very vast, large, little city is the way we treat it. And
how many of us are there now? Over 30,000? Well, more if you include everybody.
yeah, I think it's approaching probably 30 to 40,000 people at this point. Yeah, if you depend how you count it, now you add it up. But yeah, and we're growing, and there's always initiatives for newer buildings or renovated buildings. And when we do that, we keep in mind on how we build those buildings. We're required to build within a LEED Silver guideline, which means we have to make sure that different technologies are installed to manage how consumption of power is done in those buildings, how we use water, how we use electricity, gas. So there's a lot that goes into how those buildings are designed and how they're operated. More importantly, after they're built.
You're the one that fucking watches that.
Thank you. And Ben, what did you
Hi, so I'm Vin Sullivan. I'm the
what
executive,
you up to?
executive director of the Faculty Student Association, and our job is to provide services on campus. And as Terrence had mentioned, it is a small city. And there's a series of services that occur in addition to the educational and the living and the other things that folks are doing while they're here. We do everything from providing course material to providing some financial services, laundry, vending, but the big one's dining. We work with a series of some dining contract partners on West Campus, and then we actually self-operate. We employ about 200 dietary folks at the hospital and East Campus, provide the food service there. And so, you know, the question of course comes up like, what's the food guy doing at the energy conversation? But the fact is, it's just a variety of ways, and it's all sort of very tactical where this conversation can be seen, especially in the services that we provide. We are a major consumer of energy, so in a lot of ways, I'm Terrence's best client. We're also a major producer of waste products. So, you know, we touch into things like consumerism. We use a lot of petroleum single-use products and are actively reducing those. But again, I have direct relationship to energy supply. When you really think about food and you think about services in general, it's a combination of an idea, people, raw material, and energy, right? And those things combined actually produce the items that you see. And in many ways, whether you're seeing changes in prices or fluctuations in the availabilities of foods, they're directly resulted by those changes, direct results of climate change and the cost of energy. And so in a lot of ways, the sort of end product of everything that these folks are studying and discussing is going to show up in the food supply and also the services that you experience and in the expense associated with it.
Interesting. So, Devinda, tell us a little bit more about this hydrogen economy. How would that be? Tell us what it is firstly, and then how would it be implemented? And how would you create the hydrogen? Do you want to talk about that?
Sure. So the concept of hydrogen economy is not new.
No.
We knew about this 50, 60 years ago. So what is new now? That's the point.
Mm-hmm.
And the reason I'm saying that is because everybody knows that hydrogen doesn't exist. Very small fraction naturally. Unlike natural gas, which you can just dig it out and you get it. So because of that, it's not a primary source, it becomes more expensive to make. So that's where there has been an issue. And of course, 3/4 of our planet is water. So therefore, if you can find a way to make hydrogen from water, that's the greatest thing, because you basically get it from water, then you burn it, you get the water back.
Mm-hmm.
But there's a technological issue, thermodynamic issue, and that is that the way it has been known for, since we know about this, you can electrolyze water to produce hydrogen. Problem is that because the electricity is required, is expensive. Electricity would mean that the net cost of the hydrogen is very expensive. So therefore,
take more energy.
well, at one point, that's what I said. It has been known for a long time. In fact, even during the 1990s and even 2000, when all these the Kyoto protocols and other acts were being to the US were signed. The UN. Turns out, US actually opted out of that because they said, we are going straight to hydrogen. Okay, because we just want to decarbonize everything. But the problem is, as I said, so there's some technological issues. So what has changed in the last, I'll say, 15 years, 20 years, is the introduction of solar and wind, offshore wind. And why I'm saying that? Because number one, those two are the renewable sources of electricity, power generation. The second is, if you look at the price, in the last 30 years, what has happened with solar is just amazing.
I mean, the cost of installation has gone way down.
The cost of production.
Yeah.
Okay. Same thing's happening now with just out of the offshore wind, our own shore here, offshore, Long Island. So, you know, there's already a commitment for 9.4 gigawatts of offshore wind. And there is actually, there's a new block going again for auction. And I think so it's going to be increased. We probably are the largest Long Island in the country at this point, the offshore wind, in terms of how it's being developed. So we are very unique in that. So what is happening with that is price wise.
Yes.
So the price is going down. That would mean the electricity that is being generated. You know the problem with the wind and solar is, right? It fluctuates during the day. When the wind is blowing, when the sun is shining, you get it. When it's not, you don't get it. So the problem has been how to, this fluctuations, how do you smoothen the curve? And to do that, you can intercept when you are producing a lot of electricity, is a pricing issue. And then the pricing will go down. At that time, you produce, for example, hydrogen, choosing that. That is the whole premise at this point, why hydrogen had picked up in the last, I'll say, 3 years, to a point that the federal government alone has announced $9.5 billion put in hydrogen.
Now, isn't some people worried about hydrogen being dangerous? I think of Hindenburg exploding. It's you know, it's the lightest gas, and so it's really
No question.
attractive.
You know, in fact, for 2 hours ago, there was a webinar about that.
What?
There was a webinar.
A webinar?
Yes,
About the Hindenburg.
on the, no, not Hindenburg, but safety issues and other issues with hydrogen. So you're exactly right, but the thing is, if you did not know, in Texas, there was 1,600 miles of pipeline that carries hydrogen every day.
Where? Where is
Texas?
it? Texas.
And surrounding it, 1,600 miles.
So where is it coming from? Where is it going?
No, well, they are right now, they're producing from cracking methane. It's called gray hydrogen. I don't know whether you know that hydrogen has a lot of colors these days. I always thought hydrogen is colorless, but according to the science now, they have a lot of colors. Well, we color coded them. So you can take methane, crack it, and you can waste to process called steam reforming, you can make hydrogen. It's inexpensive, but it produces CO2. So that is not the way you want to go, unless you sequester it, called sequestration of CO2. But there's in the New York State, focus because of the offshore wind is on green hydrogen from electrolysis.
That's good to hear. Terrence, once I was going to work on South Campus and there was some workmen digging a big hole in the road, and I asked them what they were doing, and they said, well, we've got gas leaks, and the old cast iron pipes are 50, 60 years old and they're starting to corrode away. And I said, how much do you think we're losing? And he said, on campus, he thought we lost, and it's mainly methane, I guess, is it? 25% of what we're buying. I'm just wondering, do you think that figure was accurate?
No, I don't. I don't know who you were speaking with,
You have to say that.
We have a pretty ambitious program in looking for gas leaks annually within our plants and throughout the campus. You'll notice driving on the way in today down Engineering Drive, there's potholes strategically placed down the middle of the road. We just did a gas survey over the winter break. So that's something that we're very ambitiously tracking and making sure that we're keeping track of. Most of our plants, there's a little bit of a misnomer on our campus. So the cogeneration plant and our boiler plants are fed by a high pressure gas line that comes in off of the easement that's fed to us by National Grid. We also have an internal gas system that's a lower pressure gas.
So not
system.
everybody will know where the calpine generating plant is. That's a big white box over there by the train station.
Right. So
that's running 24 hours a day.
So that's 24/7, and that feeds our east and west campus, south campus as well. Does not feed the R&D campus. Clearly does not feed Southampton campus. But so for the most part, 90% of our properties are on a cogeneration facility, which is a dual fuel facility, runs on natural gas, and has the ability to run on heating.
And there's been a concern about calpine over the years that they had a sole source contract, and that we were not allowed to buy or create our own electricity Is that changing? I know the contracts are coming up for renewal in the
Yeah.
next couple of years. What's the story there?
So the way we looked at the Calpine contract as it came up for renewal, which is this time next year, is number one, the overriding concern was we need the ability to migrate towards alternative energy and alternative energy sources. But number two, we also know the reality of where we are at the market today, and we needed a bridge to get to the alternative energies. So we're looking to extend that contract for a short term as we start to ramp up into our alternative energy strategies, whether it's off-site solar or on-site solar or off-site wind, offshore wind. So there's a whole mixture of different things that are in the bucket right now to work on our energy strategy and to be able to number one, hit our goals, but number two, to be a more efficient operation and a cleaner operation. So that's what our goal is.
So Van, whenever you walk into a deli or a restaurant or even a supermarket, I mean, you're always stunned by the fact that everything is in plastic these days, and it's got more and more apparent in just about everything. And there's a struggle between, I mean, the need to keep the food hygienic, attractive looking to the customer. You know, they can finger it without touching it, sort of thing. What can we do about this? And related to that is recycling. And what do we recycle on campus? Or what should we recycle on campus? Can you talk about those issues?
Yeah, so it's an interesting topic, really, because now from a social perspective, so much of it really actually shows up in convenience more than in necessity, right? And so if you look at sort of the combination of energy and raw materials essentially makes the food, right? And that sort of has its various iterations down to the various ingredients, right? So there's raw material and energy that went into it. And now you've got the food's prepared to be consumed, but for our convenience, we choose to package it, right? Now, it can in many ways affect the cost if something has a longer shelf life or turnover, availability, the way that we ship, et cetera. But at the end of the day, it's our willingness to either absorb a higher cost or to absorb a less convenient lifestyle that's going to allow us to ultimately make a change in the way that we produce this waste. So that's sort of the first piece of it. The second piece of it, though, is I look at other mandated changes that we've made in our lifetimes, and I look at the prevalence of recycling. I'm old enough to remember when there wasn't really prominent recycling, and it's relatively prevalent. Or I look at things like tobacco smoking. I'm old enough to remember when my professors smoked in class, right? You know, one would dream of these things, and cigarettes were sold on campuses. And those are changes in social behavior that were legislated, were bought into, and actually very functional, right? So somewhere between those three things, looking at our willingness to pay for things, looking at our willingness to have changes in convenience, and looking at our willingness to sort of have a social compact to get together, I think we can reduce the completely unnecessary use of all of these.
How do you get that message out? I mean, you're the CEO of the Faculty Student Association.
So we do actually do a lot.
How does it work? I mean, I don't know enough about that.
So we've made a series of commitments to use compostable or fiber-based products. We made a series of commitments.
Like what? You mean knives and forks?
The knives and forks are actually, we're in the middle of converting to plant-based plastics. But hold that thought, because it's not so great. All of the to-go containers are fiber, and they're relatively easy to biodegrade. The plant-based plastics aren't so easy. We made a commitment during COVID not to use plastic bottles. We continue to use aluminum and metal bottles. We use dishwashers. We encourage folks to use China. We're adding dishwashers. And we really try and communicate, I think, in a very tactical and sort of fungible way, some things that folks can do, right, to reduce the use of those plastics. But I'd like to argue that even the use of better trash is still a very expensive way to make dirt, right? And so it takes a lot of carbon to process those plant-based plastics and the processes that ends back in the soil. And that the real answer is to continue to simply use less of these disposables and to menu our way around them, to use China, to use washables, to use reusable containers. We have reusable cups you can use, reusable containers you can use, and to continue to educate our constituency on that. Because it's something you can actually do and give you a sense of control and actually make a change in our energy consumption.
So I suppose our students really grew up in the age
Yeah.
of the, you know, there's no stopping tomorrow. It's so why worry? I mean, it's a wonderful thing to have all this convenience of plastics, right?
Yeah, and you know, I look at our students and there's one huge change that's become very prevalent in the last, I'd say 5 to 10 years, which is water bottles, right? All of our students have a water bottle. All of their backpacks have a water bottle slot. And our students really use them. They use hydration stations and they're really far differently looking at bottled beverages than they used to, right? So the responsibility for folks in my position is to make sure that those alternatives are available. So we're not just making only plastics.
How do you do that? I'm curious about you as a person in your job.
Yeah.
How do you get that message out to the student body? Do you have a team of students who are volunteers or?
So we work with the USG Sustainability Chair. We work with the eco clubs and the various clubs within USG. We have a variety of students who will approach us independently. And we do a great deal of programming. We provide a lot of support for Earth Week, work with SoMAS. And we do a lot of sort of outreach to try and get the message out on better practices. But I have to make them available so that they can be practiced. So that's my big role as well.
We're changing a big machine that we all live and work in, right?
Yeah.
This campus. And here's another question, David. I know you're a world expert on gas. What's your view on fast breeder nuclear reactors, which claim to be able to produce a waste product that's got a half-life of 50 years rather than 10,000? Is that a
Good question.
Can we get off carbon fast enough to save the planet?
Yeah, so, you know, so I teach a class on sustainability, right? So this question comes up all the time, and the question really is let's go back a little bit of history of just nuclear, not even just fast breeder. Fukushima, I was actually in the State Department at the time in 2011 as a Japanese science fellow when that accident happened. And within that bureau.
For those who don't know, this was in coastal Japan.
Coastal
There was an
Japan.
offshore earthquake, a tsunami.
Double whammy.
Yes, and
And everything basically just went down and both got, right? Now the problem really is at that time. So in fact, the person who was in charge, I was talking to her all the time. She was the one going to Japan all the time for the State Department from outside. Japan had such a golden opportunity at that time to switch over to geothermal. Why? Because you look at the location, geographic, right?
on the Ring of
You know,
Fire.
Ring of Fire. I mean, doesn't matter, don't go too far in Japan when you see another geothermal well coming in. So problem was, people thought they were going to switch over. Didn't happen.
Why? Why not?
Well, exactly the point. So that's going to bring me to the nuclear part. So why did that? It did not happen because, believe me, State Department was very, very closely working with the Japanese government, trying to see how they're going to, because it's part of I was in the Bureau of Energy Resources. They thought they were going to switch over. And you know why? Biggest problem is Japan is such a unique country in a way where they import all their energy. There's nothing they got. They only have geothermal.
Where do they buy the oil from? Russia?
They buy from everybody. They buy from Middle East all the LNG, natural gas. They buy oil from Russia and other countries. But that was actually a very, you thought, sensible thing to do to switch over to a domestic source, which is geothermal. Right.
So if you were.
You know why?
No, I don't. You tell me.
Supposedly, it is actually built into the Japanese culture. I spent a year, a month in Japan, traveling all over, and turns out it's built into their culture. They actually almost worship these sun, this natural path. They didn't want nothing to do with it switching over because they thought it was going to turn into something else. So because of that, you know, they switched back to natural gas? You know that.
No.
That's what they did. So instead of going to geothermal after the nuclear went down, they would not switch over to geothermal, they rather have natural LNG.
And all that gas.
More
is
important,
bought by ship.
liquefied natural gas, LNG,
Be
yes,
Very careful, I understand,
right?
bringing these ships into port.
Yeah, but it's a fairly safe operation, that's not the issue. But I'm just talking about why you asked me about I went to geothermal, to give you an example of that. Go back to what you asked me before about the breeder reactor. The problem still is nuclear energy. For some people, you can look at the polls from the people's perception, right? Everybody wants to do a cleaner. When they ask nuclear, they go over 76%, they want to do it. Then they ask, the next question was, can we put it within 5 miles of your radius where you live? Answer is no. There's your answer. It's still the perception issue with the
I
nuclear.
know, and long.
And nothing to do with safety. Safety has been proven. They want to go to a smaller nuclear reactors, right? But still, is the public perception is still.
What's your view? You haven't told me what your view is for small. fast
They are
reactors.
probably the safest thing, but the question is going to be, if we make it really small, can we, in terms of safety issues, safety not somebody trying to steal. So that's come to a point, it becomes so small that somebody turns, so those are separate issues. Not a safety issue, but another safety issue.
So change the subject completely. Terrence used to be director of transportation, and we live on suburban Long Island, an island that developed over the last 50, 75 years because of the automobile. You can't survive without an automobile, basically. People try to live a normal life on public transport. So can anything be done about it? So when we try and become carbon neutral, where is the boundary of the university? I mean, do we not care how that employee or that student crossed the border into the campus? How they got here is their business. We don't have to count that in our carbon footprint, or what?
So it's really based on calculations of what is done on the campus property proper, is how a greenhouse gas calculation is done, or carbon calculation is done. So one of the areas of focus in transportation, and I still work very closely with the group there. And one of the key focuses is, just like it is in the automobile industry, is moving towards a different technology. So right now there are diesel buses that operate mainly on campus. There are a few electric hybrids, but that is shortly being migrated over, and it's actually part of our study when we did the Clean Energy Master Plan study with New York Power Authority, with how can you migrate and electrify your fleet. We looked at natural gas busing operation probably 10 years ago. We looked at hybrids. We actually converted a bus on campus to a vegetable oil bus that burned kitchen oils. And we did that for a bit of while. We looked at a bunch of different technologies, but really it seems where the industry is going now is, and there's still some wrinkles being worked out in it, is an electric bus. Where it gets a little interesting is how those buses are operated and the turnaround time and how to recharge those buses to get them back in service as quickly as you can. So, but that's an area that we're focused and looking at within the Energy Master Plan. It's starting to electrify not only buses, but the university service vehicle fleets and everything else. And shortly it will be required.
Now, is it New York City has had a lot of success with hydrogen buses?
They have had some, yeah.
And also I think London and England. Yeah. So Van, tell us about some of the constituents of materials that we try to recycle, but because of market conditions or whatever, it's difficult. So could you give us some idea? I mean, there's various grades of plastics, 1, 2, 3, 5, 7. But what about like waste metal? What happens to all the rubber tires of our service vehicles?
So there's very active recycling within the dining process on the front end. So the pre-consumption food products are either biodigested, we have a biodigester here on campus, or they're treated.
Explain to the audience how
Yeah.
that works.
So there's a big old tank and you put it in there and you add some sawdust and a couple of things, you allow heat and time to essentially take their course. As the biological materials decompose, they become methane and dirt, essentially, or soil elements. And there's a very large biodigester under construction right now in Yaphank, which we will be actively participating in. It's a really neat piece of technology that can sort of sort and sift through trash and biodegradable materials or not. It spins them in a centrifuge and creates a slurry, which is going to come off. And one of the neatest parts of this, I'm a little off topic, that has methane that it produces. It produces a soil element, and then the rest, it produces energy. The methane can then be combined with the unusable methane that's currently coming out of the ground in Yaphank in the landfill and make that usable. So it's a very ambitious project underway in Suffolk County right now to do this. But back to the stuff we're doing here on campus, we only use number 1 or number 2 plastics. We do our very best to make these recyclable. And within our sort of sphere of control, I'd say that we do a relatively good job of getting the disposables minimized and streamed into where they need to go. Where we have, I think, some work to do is once it gets outside the sphere of our control, we then start to immediately look at that mix of convenience, right, and cost. And is it convenient to search out a recycling bin? Is it convenient to take our colored glass to a spot and return it, et cetera? And there's some work to be done there, for sure, I think, in gathering that. So the best thing I can do is put less of that stuff into the stream. I can't really control the behavior afterwards, but there's certainly some work to be done there.
This may not be your purview, but I think a lot about e-waste, electronic waste, and the world is full of old PCs, laptops, cables. It's hideous amount. So what does the campus do with all this stuff?
I'm going to jump in, but Terrence is a person who works here who actually won an award for gathering e-waste. There's a thing called Recycle Mania. It's been changed to the race to zero waste. We love participating in it, but Stony Brook actually won the e-waste award.
So, so as Van mentioned, we were very active pre-COVID in this Recycle Mania challenge, and that was one of the focuses was to collect e-waste on campus and recycle. We were also very active in tracking our recyclables, trying to reduce our waste consumption, but as well on the other side of it is to reduce our waste that goes out to municipal landfills. So to try to minimize as much as possible. So Van's organization has been fantastic in working with us to minimize the waste that goes out the gate. It's been a kind of interesting time in recycling right now due to the way the market is and the way the market is treating recyclables. As China got out of the industry, basically, it's been a market that's been a little bit fluctuating as far as what the commodity prices are worth for recyclables. It appears that it's starting to come back for cardboard, metals, plastic, and some e-waste recyclables. So it's going to be an interesting time to see where the industry actually goes in the future.
I mean, do you have a sort of a mandate that it has to be financially advantageous to recycle, and if it's not, you don't recycle? In other words, if it's costing, what's the policy of the university?
Well, currently right now there's a it's not a mandate, but we try to run a program based on waste minimization, and that's really the focus of it, to try to keep it out of the waste stream. So we're noticing recently, I think Van has alluded to, the plastics are reducing, and people are shifting to bottle fillers or things of that nature, that have their own personal bottles or utensils that they're using. So we're starting to notice an impact in the waste stream. Now we're still just kind of ramping up after COVID, and so we're interested to see where this goes, and we're interested to see where the recycling industry heads in the next 6 months, next year. But as hopefully these commodities start coming back, I think there'll be a bigger interest and a bigger push to start to really focus on the recycling program a little bit deeper.
Malcolm, if I could interject too, there's a cousin issue in food service that I think actually really ultimately will consume more energy and it is a little harder to fight, and that's the food that we source, the seasonality of it and where we source it from. I'm a shameless plug. We have a guest speaker this week. His name is Martin Seaver, and he's here to speak about seafood and sustainable fisheries. But one of the big points is, and this is, I'll bring this up for an example, is local fisheries and underutilized species, right? So a massive amount of energy goes into menuing and transporting foods that are out of season all over the world when there's a lot of food available right here, right around us. Additionally, for fruits and products that we force grow using a massive amount of energy. We then ship it all over the world using a massive amount of energy purely for convenience. And, strawberries are a great example of this. Strawberries were never a year-round fruit. There's a year-round fruit available, pineapples, melons, etc. So in addition to the packaging that food goes in, we have a responsibility in the FSA to help teach folks about the energy ramifications of the menuing, reductions in red meat, and that's certainly a path that's been.
How do you do that? I mean,
yeah.
Like Devinder and the teaching side of things. So how do you get that across?
Yeah, so we have Meatless Mondays. We bring guest chefs. We try and educate folks through teaching kitchens, signage, social media, all those sort of various methods. But linking, it's not always just about husbandry or cruelty. It's also about and animal welfare. It's also about the actual energy that goes into producing these things. And it's a wasteful methodology. It really is.
So why don't we take some questions from the audience? Anybody's online? Jeff, do we have the controls that we could, if somebody wants to raise their hand in the chat, you can ask anything you want. There's a question there.
That chat question's been there for a while.
I saw Michael Newton.
There he is.
Hey,
Michael,
folks, how you doing?
You've been a colleague of mine for 20 years.
Everybody looks great on the screen here. I'm at home watching the Zoom session. I would just say that what Van and Terrence had shared is right on point. But I would say that, with Terrence talking about the commodities, it looks like it's trending. It's trending upward, but it's always, for the last 30 years that I've been in this field, it's cyclical. It goes up and down, the markets. But they're starting to have some more normalcy to the commodity market of recycling due to more domesticated improvement in the material recycling facilities. You have to create better quality product. The other thing is, Van was talking about this food waste to energy facility. That's a real deal. They're doing groundbreaking this month, and it's huge. When you talk about making a difference, it's the #1 priority for the Environmental Protection Agency is getting food waste out of the landfills. Because what happens, the material degrades and
So does our internet.
While he's becoming unfrozen. Oh. Is everybody frozen or just Michael?
so I just think that's something for
You froze for a second, Mike.
We lost the punchline of your little chat. I should say that Michael and that circus promoter friend of yours, what was his name, got me into this Earthstock business. When was that? And I said I would do it for 1 year.
Don't blame me.
I am blaming you.
It's been an honor working with you.
What was that? What was the other guy's name?
Godfrey.
Oh, Godfrey.
Godfrey Palaya.
This is hard. So let's have some more questions from the audience. Nobody has any concerns. Michael, what's your biggest frustration in this business?
Oh, that's a loaded question.
Oh,
I would say that, honestly, been doing this for 35 years more. And I would say that it's an ongoing challenge to constantly educate the public and to raise people's awareness that it's very primal: clean air, clean water, clean land. And I think the message that we all have to be conveying these days is everybody can make a difference. What Terrence is doing in the power plant is phenomenal. It's been a long road for facilities in improving our facilities in a lot of different ways to gain greater efficiency. But I think that the message we have to share at Stony Brook University, a population of around 42,000 people, we're a city that can move mountains and be a difference for others to see that we can, with our footprint, make a difference by our various actions. There's a lot to look forward to. I mean, what Van's going to be doing in the next few years is phenomenal in reducing the waste stream. Just to bear in mind, if everything goes as Van and I think, with Charles Vigliotti and this facility that's being built, 60% of the waste stream from campus dining will be diverted for high-grade compost and for energy. That's phenomenal. Right now, it's not going there. So that's something that we do have on the horizon. And I have a positive view of our future, because each and every one of us, whatever we do, it adds up. So that's a big question. It's a fair question. But I think that if anybody's listening on this call, Zoom, you know, we have a lot to look forward to. I mean, Stony Brook University is doing a lot of good things. And I enjoy working at the university, and I enjoy seeing the positive steps that everybody's taking.
Well, thank you, Michael. On my left, just off the camera, is Dean Paul Shepson of the School of Marine and Atmospheric Sciences and Sustainability Studies. Why don't you come over here, Shep, and tell us a bit about, drag your chair over, because you can't see it. Tell us how you see our school being part of this revolution of becoming a carbon-free economy. Can you be, there you go.
Well, you know, I was going to ask a question.
Well, you can ask.
Our science is mostly on the driver's side, the motivation side for mitigating the impacts of climate change. We study climate change and its causes, which are really well known. I'm excited that we are part of New York State, which is a leader in the country and in the world in terms of its legislation, Climate Leadership and Community Protection Act, that mandates the schedule for reducing greenhouse gas emissions. It's a very ambitious schedule, but interestingly, so getting to my question, Stony Brook created, as I heard Terrence mention, the Clean Energy Master Plan, which more or less sort of attempts to mirror the legislated schedule for the state. That would make Stony Brook a partner with New York State in achieving the goals of what we refer to as the Climate Act. So as I recall from reading that plan about a year ago, it calls for things like converting our energy production in a significant way to solar, that we would have solar panels all over much of the roof surface area, which is actually in the scoping plan for the CLCPA for the whole state, that in order to meet the goals, we'd have to cover something like 40 to 50% of all the available roof surface area. At any rate, it's an exciting time to be part of converting to zero emission electric power production. My question is, Stony Brook and SUNY are resource limited. Do we have a plan to finance the goals of the Clean Energy Master Plan? How do we, you know, the goals are very lofty, ambitious, noble. How do we get there financially?
So we've had lots of discussion amongst the state. Stony Brook happens to be pretty well advanced as far as what our plan and our clean energy master plan has outlined. And we're looking to define with the state the financing options and the funding mechanisms to get towards our goals. So we were working with New York Power Authority as well as with different entities in the state of New York to try to understand just that. So as we round out our clean energy master plan, the East Campus one was just finished off, and now they've been merged into an executive plan, which will be presented to the administration very shortly. At that point in time, we look forward to the conversation with the state, because this has been a number one topic of ours. We've identified the need, we've identified how we're going to get to our goal, and how do we get to our goal. So it's something to be defined.
It seems to me that early on in the process, we might have an opportunity to be in a leadership position relative to other parts of the SUNY system in terms of creating demonstration projects. And, you know, once some of such things are funded, it will become harder. So this is sort of part of my question. You know, to what extent are we making a case that Stony Brook ought to be doing, you know, proof of concept demonstration projects along the path to doing away with natural gas combustion, which is a clearly outlined goal of the Climate Act, that we are going to phase out natural gas. We have that plan while new pipelines are being laid on Long Island. This is going to be a very challenging process, and it'd be great if Stony Brook could be a real leader.
Well, you and I have discussed that as well as with the group and as well as when we were talking through the Clean Energy Master Plan. You know, it's a multi-layered approach. You know, the industry is not set just yet, although it's ramping up very quickly to accept, you know, all alternative solutions at this point in time. It's going to be a mixture of different solutions to get us to where we need to be, with the ultimate goal of phasing away from carbon fuels.
It's actually required by law.
Right. Correct.
Right. It's not just a goal.
Absolutely.
It is required by law.
Absolutely. So, and that's where everybody's moving towards. Now, what's still trying to be defined is what's available, how do you get it, and the pricing structure and the models. And so it's a moving target as we speak. But it's something that we are very committed to and that we're pushing towards ambitiously. But like I said at the beginning, though, it's a multi-pronged approach. There has to be some recognition that there will be some carbon, there'll be some solar, there'll be some wind, there'll be some other alternative use, whether it's biomass or whether it's nitrogen, whatever the conversation may be. That's going to fit into the overall picture long term. That's going to be able to help us and help the state move away from.
Jeffrey, Jeff Levington, thought I saw you. Are you still there, Jeff?
I am here.
So you're hidden behind a big white rectangle, but Jeffrey, I have to pay tribute to Jeffrey because he is my co-academic chair of Earthstock for many, many years and has been a tremendous source of ideas and inspiration and energy. Jeff, you're a famous ecologist. Tell us, what is the changing climate doing to Long Island, and what are some of the threats that the island, not just necessarily Stony Brook University, but all of us are going to face in the next, say, 30, 40 years?
Well, that would be a long topic, but in the shortest thing to say is that warming is real. All of our estuaries in the East Coast here, the Northeast, are warming. It's a little embarrassing that we didn't really measure temperature in many of our estuaries until recently. The only place we really have coastal measurements for a long time is in Woods Hole, Massachusetts. That's a great embarrassment. But for the last 25 or 30 years, we are seeing measurements everywhere, and everywhere there's warming. And warming has all sorts of ominous influences, things that pile on to the terrible condition of our estuaries right now. I've been recently working on this on a book on estuaries, part of it anyway. And the decline of our estuaries because of human interference, especially nutrient addition, as our colleague Chris Gobler has told us, and every year he gives us the most incredible tour de force lecture about the state of the bays on Long Island. And the story every year is disaster and getting worse, and with some plans. But the situation is really very bad in estuaries around the world. And warming is facilitating invasions. It is causing reduced oxygen. There's all sorts of problems that are really very worrisome. And I have to say that as a citizen of Stony Brook University, I want to see us identify ourselves even more than we do. But I'd like to thank especially Dr. Gobler and many of the other people on campus who've been so concerned about the effects of climate. But I think the campus here, I'm going to say now as a personal opinion, I don't think we really have conveyed to our citizens, that is the students and the faculty, this energy, which apparently is a wonderful energy going on behind the scenes. It's so behind the scenes that most of us don't see it. I would say Mike Udelman is the greatest public, he retired recently, but he was the greatest public exponent where everybody saw because of his incredible energy with recycling. And there, I think we have a visibility on campus, but I don't see the energy about energy, for example, solar or wind or anything else on campus. I don't see any symbols even. I don't like symbols that don't lead to advances, but I'm very worried that our campus really doesn't look very forward-looking, really, even though things are happening. So I know I would get a lecture about all of the meetings that are occurring, but I think on campus, I don't see it happening. I'm worried about that. I'm also worried about the fundamental waste of energy of having all of our commuters. So many students are burning gas coming here. And all of these things don't make us look all that good. I'm sorry to say. I'm not saying we aren't good. I'm just saying we don't look so good. And I found it hard, for example, recently as a retiree, figuring out how to recycle glass in my own building. I couldn't get information. So I think we have a long way to go, and certainly our region has a long way to go. Although there have been some very major improvements, I have to say that thanks to researchers and energy in Long Island Sound, especially in the state of Connecticut, I'll say, we have a tremendous improvement that we've seen in Long Island Sound in its quality and its oxygen concentration, and things are getting better. But we really need to make the visibility of all of this a great deal greater than we've done. Despite the fact that we're a great center of the environmental movement. The environmental movement started right here in New York State with two great organizations. And yet, I think still the Stony Brook campus is, I think maybe could use a little more visibility.
That's a good marching instructions from a very wise man, Jeffrey. So Devinder, in a way, you may include the Gas Research Institute over there on the research campus is kind of hidden away. And thanks. So how can you somehow bring the message to campus more? I mean, you're doing it right now, actually.
Well, I think Jeff actually has brought on really good points, because given that we are a university, our best bet is to make sure that a lot of students get involved in this research. I I actually have to say that the institute right now has 10 graduate students and about 16 undergraduates for 26 students. So
In chemical engineering.
in the research,
So it's
in the
like-
research. It's not just chemical engineering. Let me clarify. The Gas Institute does not just take chemical engineering students. Students are coming from all across the campus.
Mhm.
And one of the things that is happening, remember I tried to make a point that I can have probably one of the best technologies. If the public doesn't want, it's not going anywhere. How's that?
So it's a huge education challenge.
Exactly.
And I think we all can agree with that. And you just cannot stop it because you think you've spent 5 years educating everybody, but then students move on.
You need to
Another
bring more.
curriculum, you've got to keep doing it over and over again.
Exactly. So I think that's probably one of the biggest challenges to make sure, since we have the student body here,
Yes,
that they actually get involved,
yes,
right?
yes. Well, on that note, I think we better close this down. It's been very, very interesting. We're just over the hour. And I thank you all for being willing to give your valuable time to the panel and to all those out there. We hope you found it somewhat useful, and we will continue the discussion.
Thank you.
So thank you, everybody. And
Thanks, everybody.